Okay, last picture you saw Harry taking off in Malibu and driving his car up the hill and away. He's had the car better part of
more than a year.
This year and driven around 800 miles. It's back here now in Michigan. Obviously, Malibu doesn't have snow on the ground. He had some relay failures. He had this little box. I don't know if you can see that under the dash. It switches between an economy mode, normal driving mode, and performance mode. It regulates the amount of amperage that is sent from the controller to the motor. That is going faulty, either a wiring problem or an inherent problem in that switch, and it's fluctuating between the three settings, so that even in performance mode, whenever it feels like it, it gives you half your voltage. So you feel the car slow down, then speed back up. We noticed it when we drove it. He had a cutting out problem. We got that fixed. The battery charger in the trunk that charges the 12-volt system was not enough amperage to counteract using the lights and the air pump for the brakes. It would slowly drain the 12-volt battery down. And even though we have a DC to DC converter, which is supposed to put power back into that battery once it drops below 12 volts, that system or relay also failed. So the fail-safe failed. So we're going to put a higher amperage 12-volt battery charger for the 12-volt battery. We're probably going to downsize the battery, move it. You want to pop the hood? Probably going to downsize the battery and move it. And we need to open this thing up for more air. His motor is overheating. We got the controller here kind of in the way of the grill area, blocking some of the airflow. We're considering taking this battery out, downsizing it maybe to half, putting it over here, cutting this area out larger, and dropping this controller down in this location. We'll move this DC to DC converter. We can move these batteries around, raise them up, move the controller back, downsize this battery, move it over here. Doesn't need to be as large as it is if everything else is operating properly. Just need a battery for a buffer so that when the air pump kicks on, lights don't blink and flash and things like that. So this will probably be able to stay where it is. May have to move a few the air canister, we're not sure. Colin has gotten, the company that makes the controller unit has gotten back with him and narrowed everything down again to this multi-switch under the dash. And we're going to take that out and actually bypass it and wire it direct to high performance mode. And if he doesn't want to go fast, he doesn't have to push the pedal down so hard. So he likes that, I'm sure, better anyway. So we're going to start removing electrical wiring, batteries, battery hold downs, the controller, the air pump, and rearranging things in here so that the hood will still close and that we can get more airflow down to that motor. We're still contemplating cooling tubes on the motor itself with a small radiator and a fan up front, an aluminum radiator that will help in the cooling of that motor because it is definitely getting too warm. So we'll be able to get rid of some of these fans. You got a fan here, you got one underneath that side, and there are 2 or 3 fans under here that kick on and blow air on the motor, but it still is not efficient enough not enough airflow to keep that motor cool. We'll get some shots as we go, but we're going to start disassembling and try and get a little more airflow to this motor. We got other problems taken care of. We get the overheating problem taken care of, and he's good to go. Most of the day's been spent since we last filmed removing, well, batteries and the controller, pretty much everything. The hood had to come off. We've taken measurements of this entire compartment here. There are frame pieces underneath of here. Not real feasible to put the controller in this location because of, well, a variety of things. We'd have to cut all the way to here. We have to cut out to here, take this box out, make a new one. It cuts into the frame members that go through here that we're already pretty much against. We're going to evaluate our room. The controller actually does sit right in here and still misses the hood and sits up fairly high. We can't come too close to here. There's a reinforcement on the bottom of the hood that will hit it. So it's set up, and it would sit right in here, and we'd still have room for batteries and things. So we're going to play with that idea. We've got everything removed here, but we still have an inherent problem where we still have a concern. This frame member, this cross member are all blocking air to the motor. The way that the design of the car is out front here, the nose panel is angled down, shooting air away from the motor. We can collect air coming through this grill area and divert it down, keeping the batteries up in here at a higher level. We can come up about 4 to 5 inches. We've taken a look at these supports that we built in here before to support the motor, and I'm strongly considering removing these, coming off of here at an angle, dropping down and going under and supporting the motor from the sides, getting rid of any obstructions in front of the motor whatsoever that could cause any type of airflow obstruction. Our biggest concern is, of course, this blasted cross member that the factory has designed here. Not sure what we're going to do there. We may jack the car up and take some measurements and so on, but everything is stripped down now so we can get a better feel for exactly what to do. We've also discussed laying aluminum tubing in the fins with a high temperature epoxy right down into the cooling, these fins here, and bending it back and forth and picking up half or more of these fins and along the side, and putting a small radiator off to the side up here with a small pump, and pump liquid through and cool that as a secondary cooling capability to cool that motor. We're running the motor pretty much right up near its capacity. There are some things we can do electronically to back that down 5 or 10%, and he'll still have his horsepower, but it would not be immediate all at once, so put such a load on the motor. So there's a variety of things we're discussing with the company who makes the controller, and we're going to try real hard to open up the front end of this car and divert all the airflow that we can down to that motor. So we'll get some shots as we kind of brainstorm and do a little more work on the front end here. We'll get some more shots before we put things back together.
Voltage, but
there is one more thing. We drove the car about 30 miles and we recorded all data, everything that the batteries were doing, the controller was doing, how the motor intermittently had power, better power than other times. And as I already mentioned, we determined that that switch under the dash does have a fault. The company confirmed that with us and got back to us about that. We also confirmed, according to data, that battery pack or battery set 91 was dropping down to 2.5 to 2.7 volts right away, just as soon as we started out. This is after a fresh charge. So we actually have one or two cells. We've isolated it down to this pack right here. We have one or both of this pack here are faulty. They're not shot, but they drop down too fast, too quick. And when all other battery cells around, and there are 200 of these, so when 198 of them on a hard load of pulling 100 amps or more drop down to 2.9, 2.85 to 2.9, even 3, that one drops down to 2.5, 2.55 under a hard load. It does recover itself after you back off on the pedal and so on, but it's weak, and it causes the other batteries, of course, to have to put more load in to make up for it. So we're going to change those two. We have a set of spare batteries that we're going to test. We may have to buy 2 more if those don't pan out. But we are going to replace those 2 cells. So there's 2 of them that we're not satisfied with. And, of course, has nothing to do with the engine overheating. It has to do with performance ability of the car. So we'll get back later. Today we got our circulation pump. To circulate water through the capillary tubing, we're going to attach the motor and the pump to the radiator and back. Unfortunately, the only thing we can find that'll work the way we want is 110. So we're going to have to use a converter and get some low wattage 110 volt power for this. I'll get some shots of the car where we are now. I'll head back there and we'll continue this on. We've made some decisions on what to do. We've removed the air blower fans. A few stragglers laying around yet. We've taken the heavy duty 12 volt battery out of here. It weighed 70 pounds. We're going to put one of these lithium batteries back in. And they, I don't remember. I think they weigh 12 or 13 pounds. And we're going to fix the ability to recharge those from the other battery packs. So that'll lighten things up. I might be able to tuck this down in here as well. We've got components coming in. There'll be more in tomorrow. But we got our Easy Bend aluminum. Preliminarily, I just zigzagged some of these by hand. I know it looks a little cheesy, but to see if they would fit into the tube on the motor, and they do fit very well down deep into the fins. And you'll still have about ½ inch of fin above this for also air cooling. And we've got a heat transfer epoxy coming in where we'll put epoxy on these in several spots to hold them down deep into the fins. And this will zigzag back and forth between 6 and 7 times, come back out, go to a manifold, if you will, or a reservoir, be collected and be pumped to the radiator. That should be in tomorrow. We're going to set up a little fixture on here to properly bend these, a little more professional looking, and so that we can bend up a set, cut them, take them down, and apply them to the motor. We haven't yet, as of yet, determined. I think we're going to use compression fittings here and build an aluminum manifold that these will just attach to get away from hoses and clamps and things like that. It'll make it a little more reliable, we think. So We'll get some shots of that as we get going tomorrow, and we'll show you how this is all going to come together. Okay, a bunch of stuff came in today. It's just Thursday, 26th or 27th. I think it's the 27th. This is a oil cooler, heavy duty oil cooler for like a truck, and it's for taking the transmission fluid through it and cooling off, keeping your transmission from overheating. It has a sensor on here set for 175 degrees to turn the fan on. We can either use that or have this come on at a lower temperature by changing the sensor to 150 or whatever. Blower pulls air through the radiator, has a 1/2 inch input, 1/2 inch output, multiple fins and vanes to flow across. We installed 190 SL taillight grommets in here, which actually fit perfectly, so we can mount this in rubber. It's going to set in the car in the center, right about here. We'll still get airflow through it and past it, so we're still going to have airflow down in the car. We will be putting zigzagging water tubes that we're building a fixture for right now. They'll go in every other one of these all the way around the motor. They'll come back to aluminum manifolds that should be here tomorrow that we'll hard pipe into. And out the bottom of this, we're going to put 90-degree brass or stainless steel elbows to accept rubber hose. This is a very high temperature, high thermal conductive epoxy adhesive to hold the aluminum tubing into the bottom of the aluminum fins on the motor. This material will handle, I believe, 500 degrees. The motor runs 150 to 200 degrees usually. When it gets hotter, it starts shutting things down. So we needed something that would run at a high temperature so that it can handle the varying temperatures. $60 a pint here. We are putting in 2 more fuses on board. We have one up front. We're going to break the system and put a fuse for the rear batteries and a separate fuse in kind of for the front batteries. Another water pump. We'll put an inverter in here that goes from 12 volt to 120. It'll run this at a low amperage but a good volume water pump to circulate the water. Here's the water tube. We're setting up a bending manifold here. We can zigzag, come in here with tube, zigzag around these, and because you can't get in between here very well, these are removable. So we can pull over this one, remove those, pull over this, pull over that. When we reach this one, shove another one on, come around it, come back here. When we reach this one, drop a sleeve on it, come back. When we reach this one, bend it. We're going to bend some of these up in preparation for the manifold coming in, and we'll be able to bolt directly to the manifold and run the cooling fins and epoxy them into the motor. We'll try and have that done by tomorrow and get some shots of it. But that's where we are at this point. We're going to drill these out and get these mounted. We'll be making another little bracket down here. We're going to get the blower assembly mounted in here. We've discussed mounting it off center to allow more airflow coming through one side, but we're thinking that we're going to get our best airflow in the front of this car right dead in the middle through the star, and so that's what we're going to do. Get some shots tomorrow. Get some more shots. A couple hours later here, Thursday still. Stuff came in. We made brackets, attached it. The cooler is mounted in place. We are bending up 2 sets of tubing so far. I got 2 more sets to bend up tomorrow. I got to leave. It's about 4 o'clock. we're looking at things tonight. My daughter's getting married, so looking at halls and so on. So we will get some shots tomorrow. We'll get the tubing epoxied in. Hopefully the aluminum valve bodies or blocks will come in that the tubing's all going to mount to. We're going to put in a reservoir tank, get the water pump hooked up, check how many gallons per minute we're going to get pushed through, and get all that figured out so we can get a feel for how many BTUs of heat transfer we're going to get. But it's all coming together and looking pretty good. Looks real good here through the grill. Sits in there perfectly, dead center. It's going to get the blunt of all the airflow right down through where the radiator used to be. So, looking pretty good so far. We'll get some shots tomorrow. Okay, we're back. Things have been installed more permanently, fittings and adapters. We've tested the water pump and circulation through these tubes. We bent the tubes and recoiled. Had a real hard time fitting this one because it has to tuck under this mount. Doesn't look quite as pretty on the end here, but the rest of them come out real nice. These are cardboard wax board pieces we use for door trim panels for the 190SL. They're actually being used as wedges. The black ooze in the bottom is a heat transfer epoxy. Colin is heating this really hot because the epoxy cures better the warmer it is. Matter of fact, you can actually bake it up to 300 or 400 degrees. We're not going to get that carried away, but the two top sets of tubes look ratty sticking out here, but hand me that. This manifold will bolt here, and these tubes will come out around and feed into the front. This tube here will come around and feed into the front. The other tubes out the back, there'll be another manifold sitting here this direction, and the return lines will come in after the water's warmed up from the motor. Will come in and tie into these three fittings here. They'll come out this, around through here, and up to this fitting on the radiator. Over here will be an inline water pump that will push the fluid through the motor and out. And on one of these two sides we're going to have an aluminum overflow, or a radiator canister if you will, so we can check, bleed air out, things like that, and check water levels. So this has to set for at least 24 hours. We may attempt to put the side ones on the side yet tonight and let this set up overnight. We'll probably put a heater under the hood here and just keep heat down on this, keep the motor nice and warm, because this has a 24 to 48 hour cure time at room temperature, but you can actually keep using the material almost 24 hours after you mix it. So we want it to cure up, so we're going to heat up everything. So we'll get some shots, but it's coming along. Like I said, things are painted and mounted, and we did figure out here, that's just 2 cells. We're ordering more battery cells. We can put 4 here to get them as 12 volts to run all the system. And we can pretty much take all the relays out of this metal box, drop them into the normal battery box. We can put 2 more of these lithium batteries up here on top to alleviate some of the room problems of putting batteries down in here. So it's going to progress better this week. After tomorrow especially, we'll be able to start putting things back in, hooking up, checking the gallons per minute flow once all the tubing is put around the motor, and that'll give us an idea, or a BTU transfer. So we'll get some shots in the next few days. Okay, a little unstable here, but I got a problem. It says the video head is dirty, so I don't know if this is recording or not. Doesn't appear to be.
Neither one of us heard that.
Obviously. We had a heavy insulated canvas covering this entire area like a tent, with burners on underneath the car about 7 inches away from the bottom of the motor for 2 days. And we cooked this thing up to about 150 degrees so that the epoxy would cure. And that's the epoxy is supposed to cure at 150 to 300 degrees. We didn't want to go to 300 degrees. But at 150 it needs 8 to 12 hours of curing time. So this is an epoxy that has this held very firmly in place. Steve made some little shims out of wax board, and they're pulling them out right now.
See, they looked like that before.
Yeah. They're stuck into the epoxy part way, but they wedged in and helped hold everything in. So we'll get some shots as we get the manifolds, finish drilling the holes in the top here for these manifolds. We have a radiator reservoir, overflow reservoir ordered. We're going to get the manifolds hooked up, get the tubing coming out of the manifolds over down to the water pump, and we'll leave some area. Probably we'll hang the auxiliary radiator somewhere up front here. It's not a radiator, a reservoir up front off to the side. We're going to get some things hooked up here and start making battery mounts, because we have to be able to put the batteries in here and have room for everything. So we'll get some shots in a couple hours after we get a few things hooked up. Okay, we are very close to being out of tape. So we've got an electronic fuel pump, 12 volt, running, circulating. Hang on to that. It circulated this much water in about a minute. So much better. Great flow. Unfortunately, it's nearly a $300 fuel pump. It's a used one from our friends across the street. But it's doing a marvelous job pouring. You have that jammed to the bottom.
Oh.
And it wasn't picking up.
Okay.
So it was making, that's why it was making a noise.
No, we need to shut this off.
So we got great flow. Like I said, about 1.5 gallons to 2 gallons in a minute, which is about what we were shooting for. Pull that bucket out of there so I can get a shot of this before the tape stops. Okay, we got a reservoir coming tomorrow. By tomorrow it should be here. It's going to mount over here. All our lines are hooked up. Tubes, no leaks anywhere. Epoxy set up. We cooked this baby for about 2 days. We had a snow day yesterday. Pretty much no one came in. Didn't get squat. I plowed all day long. We got between 12 and 15 inches of snow. So
we actually end up getting
we'll get some shots when we get this completed and start putting the batteries back in. All right, this tape is about spent, so this could stop at any moment and just quit. But we finished the bracket. It hasn't been painted yet, but we finished the mounting bracket for the controller. We fitted an extra hood that we had on top of here, made sure that there was clearance between the fans and the hood, because the controller does come on periodically and cool itself. The fans do. You can kind of see the tubing underneath, how it looks, how much clearance we have under there. Quite a bit. There's like 5 inches to the bottom of the controller from those blocks, about 6.5 inches from the actual motor to the bottom of the controller. So next couple of days, we got our reservoir here. We'll pipe later today. This is Saturday, February, I believe, 4th. The motor controller cable will go into here. It's just set there for now. It's not hooked up. Get some shots. We're going to start working on battery mounting brackets for the sides here. Get a feel for how many batteries we can fit. We think we can fit one battery right in top here where the old big battery was. So we may have to switch tapes here before we do any more, but we'll get some shots, get this set in here, painted, bolted in place, and then start making some battery trays, and then we'll get some shots of that.
Drop it off into something there.
Okay, we're still running on that same tape that's going to die out here any moment now. We kind of reorganized this entire box, labeled all the wires, labeled all the relays, got everything set. This is mounted. Just got our electric fuel pump in. We're just getting ready to finish piping it. We'll have this up in circulating water probably within 10-15 minutes here. It's Tuesday. What's the date today? February 8th, Tuesday. We got antifreeze. We got a material called Water Wetter, which is an extra lubricant. It makes the water work better, makes it cool better. So we're going to get this put together here and get some shots of it soon. Still on the same tape. It's still hanging in there. Antifreeze and water is in the mix. Pump's operation.